Sazwani binti Zakaria with my truth number 207061. Before we start, let's understand what HIRARC stands for. HI refers to hazard identification. Hazard identification is recognizing of things which may cause injury or harm to a person. RA stands for risk assessment. Risk assessment is looking at the possibility of injury or harm occurring to a person if exposed to a hazard, while RC refers to risk control. It is to measure which will eliminate or reduce the risk of a person being exposed to a hazard. Before the process of identifying any hazards begin, it is necessary for us to know how to classify hazards, risk and danger. Hazard is anything that causes harm. Risk is a possibility of harm actually being done. And lastly, danger is the relative exposure to a hazard. For this video, we will explain two chemicals which are acetic acid and calcium chloride. First and foremost, the hazardous chemical that we usually use in our lab is acetic acid. Acetic acid, systematically named ethanoic acid, is an acidic, colorless liquid and organic compound with the chemical formula CH3COOH. Other than that, it also has a pungent smell. At STP, the melting point and boiling point of acetic acid or ethanoic acid are 289 Kelvin or 391 Kelvin respectively. The molar mass of acetic acid is 60.052 gram per mole and its density in the liquid form is 1.049 gram per centimeter cubic. Acetic acid is flammable and can form explosive mixture with air. To minimize the risk of fire or explosion, acetic acid should be stored in proper containers away from ignition sources, heat and open flames. Adequate fire suppression systems such as fire extinguishers should be available in areas where acetic acid is stored or used. Moreover, acetic acid vapors can be irritating to the respiratory system when inhaled in high concentrations. Prolonged exposure to high concentrations can cause respiratory tract irritation and damage. To address the hazard, acetic acid should be used in well-ventilated areas or under fume hoods to minimize vapor exposure. Respiratory protection such as respirator or mask should be used when working with acetic acid in poorly ventilated areas. In the event of a spill or leak involving acetic acid, person not wearing protective equipment and clothing should be restricted from contaminated areas until cleanup is complete. The following steps should be undertaken following a spill or leak. The first one, do not touch the spill material. Stop the leak if it is possible to do so without risk. Second, notify safety personnel. Next, remove all sources of heat and ignition. Ventilate potentially explosive atmosphere. If the vapor from the spill has not ignited, use water spray to reduce the vapors and to protect workers attempting to stop the leak. Absorb small liquid spill with sand or other non-combustible absorbent material and place the material in covered container for later disposal. And the last one, for large liquid spills, build ducts far ahead of the spill to contain the acetic acid for later reclamation or disposal.
The second hazardous chemical that is often used in the lab is calcium chloride, or it is also called calcium chloride anhydrous. My name is Sarah binti Ibrahim and my metric number is 206614. And I'm going to explain about the safety in the laboratory when handling chemical CaCl2. But before that, let me explain a little bit about the properties of calcium chloride that everyone should have known. Calcium chloride is an ionic compound of chlorine and calcium. Calcium chloride has numerous physical and chemical characteristics. At room temperature, it is a crystalline solid white in color. The molecular weight is 110.98 gram per mole and the density is 2.15 gram per cm cubic. And at temperature of 772 degrees Celsius, calcium chloride starts to melt and it can be boiled in the high temperature because the boiling point is 1935 degrees Celsius. Before that, let me explain a little bit about the properties of calcium chloride that everyone should have known. Calcium chloride is an ionic compound of chlorine and calcium. Calcium chloride has numerous physical and chemical characteristics. At room temperature, it is a crystalline solid white in color. The molecular weight is 110.98 gram per mole and the density is 2.15 gram per cm cubic. At temperature of 772 degrees Celsius, calcium chloride starts to melt and it can be boiled in the high temperature because the boiling point is 1935 degrees Celsius. This chemical has been classified as hygroscopic, which means that it absorbs moisture from air. Basically, hygroscopic substances are used to remove water or drying applications, but if the hygroscopic chemicals spill in the laboratory, it can cause various effects and consequences. One of the effects is it increases the chemical reactivity. Hygroscopic substances can become more reactive when they come into contact with water. This can lead to the release of heat, generation of gases, or even the initiation of chemical reactions. So, the precaution step that could be taken while handling this chemical is to have appropriate absorbent materials, such as spill kits or absorbent pads, readily available to contain and clean up spills promptly, and it needs to follow proper disposal procedures for contaminated materials. Calcium chloride also has been classified as harmful chemicals that can affect the organs in humans' body, such as eyes, skin, ingestion, and inhalation. This is because the release of toxic fumes or gases from reactive hygroscopic chemicals can pose health risks to laboratory personnel, causing respiratory issues or other adverse effects. Additionally, it also can be toxic, corrosive, or hazardous to aquatic life if they enter water bodies or the sewer system. So, back to basic, wear an appropriate PPE including gloves and safety glasses when handling hygroscopic substances. This will help to prevent direct contact and potential skin irritation. So that's the end of the video about HIRARC.
No lab safety, no pain. Thank you.
Thank you.